Hello geometry students, this is Mr. Fugay, and for this video we are going to talk about ratios and proportions, and specifically how they apply to us in the geometry course. So this is going to be an overview of two topics that you've learned in the past, and if you wanted to do a deeper dive into each of these topics, I do have some supplemental videos for you. So let's start with our first term here, and that is the word ratio. A ratio is a comparison of two quantities, and we use division to separate those quantities. In other words, it's a fraction, and each value of the fraction is one quantity that we're comparing to another. There are three ways that we represent ratios. The first is a traditional fraction, as you may be familiar with here. The second is using this colon symbol to separate the two quantities from one another. And lastly, sometimes the word to is used. All of this means the same thing. Now, if you're looking for a deeper dive into what a ratio is and learn a little bit more about it, I do have this video over here by Math Antics. It's about 10 minutes long, and it specifically goes into what a ratio is, why it's used, and so on and so forth. What I'm going to spend the time on this video is showing you some of the different ways we need to work with ratios in geometry. So in our first example, we are going to talk about how to simplify ratios. And note at the top here, I wrote that in order to simplify a ratio, simplify a fraction, the quantities must be in the same units. So if we look at example A here, we use in the colon format. I almost always will convert it to the fractional format, simply just because it's easier and more intuitive for us in math to use. So I have the quantity 64 over 6. Because both of these are measured in meters, they are the same unit, therefore I can simplify it. I believe, if I'm not mistaken, they both go into 2. So I can simplify 64 over 2 to 32 over 3. And so there it is. That is my ratio. Again, if you want to write it as a colon format like this, that is obviously okay as well. Now, if we look at the second example, we have a little bit of a problem here because the numerator is measured in feet, the denominator is measured in inches. So we cannot simplify this ratio in its current format. What I normally recommend to do is we take the larger unit, which in this case is feet, and we're going to convert it to inches first. So as a side note, I know that 12 inches equals 1 foot. Therefore, if I'm looking for 5 feet, that's 5 1-foot increments. That's going to essentially be 12 times 5, which is 60 inches. So the equivalent ratio that I will be allowed to simplify here is 60 inches over 20 inches. This is the one we can now simplify. And when I do that, 60 over 20, well, they both go into 20. So this is going to give me a 3-to-1 ratio. Now, we know when we write fractions, if you write 3 over 1, you can just write it as 3. But because we're specifically talking about a comparison of two quantities, I'm probably going to leave it in this 3 over 1 format, or if you want to write it with the colon format, a 3-to-1 ratio like that. So now it's your turn. I'm going to have two examples here on the guided practice. I would like you to pause this video, try these two examples, and I will be back in a moment with the answers. Let's take a look and see how you did here. So for the first one, 24 yards to 3 yards, I wrote it in a fractional format that you see right here. Since they were both yards, I was able to immediately start to simplify. They both go into 3, so that gave me an 8 over 1 ratio. Again, we know the whole number 8 is the equivalent answer, but since we're talking about ratio, we're comparing two quantities, so 8 over 1 or 8-to-1 ratio. For the second one, we did need to do a conversion. I noticed I did give you what that conversion was down below here. So when I converted this, since 1 meter is equivalent to 100 centimeters, I took 6 meters and essentially multiplied by 6 to give me a 600 centimeter equivalent. It's always recommended that you take the larger unit and convert it to the smaller one. It saves us dealing with fractions and decimals within other fractions. So now we're simplifying 150 over 600. They both go into 150. So when I divide it, I got a 1 over 4 or 1-to-4 ratio. The second thing we want to be able to do with ratios in this course is to write equations. So I have two different examples here. The first one says you are planning to paint a mural on a rectangular wall. You know that the perimeter of the wall is 484 feet, and the ratio of the length to its width is a 9-to-2 ratio. Find the area of the wall. So let's start with the idea that we're talking about a rectangular wall, and length and width is how we measure the two main measurements of the rectangle. When we want to find perimeter, perimeter is adding all of these up. And so for a rectangle, the perimeter would just be 2 L's, so L plus L, plus 2w, w plus w, equals our perimeter. Now, in this case, our perimeter is 484 feet. We already know that. But what we need to do now is we need to talk about what we're going to call our length and what we're going to call our width. Now, when we talk about a 9-to-2 ratio, right? So we have length to width is the ratio we're looking at, and it's a 9-to-2 ratio. That could be a variety of different things. It could be, well, 9 feet and 2 feet. It could be 18 feet and 4 feet. It could be 90 feet and 20 feet. It could be 900 feet and 200 feet. We don't know which of these it's going to be, or it could be one that I haven't even listed. But one thing is true, is that if I were to apply an x to this, a common multiple between these two, an x and an x, then essentially I could look at this 18-to-4 ratio as x equals 2, because when you multiply by 2, you get 18 and you get 4 respectively. In this one, we can look at this as x equals 10. 9 times 10 is 90, 2 times 10 is 20. And for this last one, we can look at it as x equals 100, so that's where we get the 900 and 200. Our goal is to figure out what x is equal to. So that's ultimately what we're looking for. So in this situation, when we're given a 9-to-2 ratio, I'm going to assign this x to it. Our scalar multiple is what we call it, but it's a common multiple that we would apply to figure out what would meet the criteria of this ratio. So we're going to do 9x for my length, we're going to do 2x for my width, and we're going to go ahead and we're going to solve this equation. So we get 18x plus 4x equals 484. 18 plus 4 is 22. And last but not least, when I divide by 22, we're going to get 22 as our answer. Oh, that was a perfect square. So what that means is if I plug 22 in for my ratio and I plug it in, I would get a length and a width that would be equivalent to a perimeter of 484. So what is the length and the width then? So if my length was denoted by 9x, we would say my length is 9 times 22, and that can give me 198. So my length is 198. My width is denoted by 2x, so we're going to do 2 times 22, which is 44. So my length and width is 198 by 44. If we want to find the area of a rectangle, we're going to multiply those two together. So that's going to give me 8,712, and we would say feet squared since we're talking about an area. So that's one example of using ratios to be able to solve for something. The other, we're going to talk about triangles. It says the measures of the angles in triangle CDE are an extended ratio of 1 to 2 to 3. And we want to find the measures of these angles. So once again, the triangles cannot measure 1 degree, 2 degrees, and 3 degrees because that wouldn't add up to 180. Rather, what we want to do is we would like to apply an x to both of these, or all three of these, I should say, so that I can figure out what that common multiple is that will allow these to be true. So if the first angle is 1x, and the second angle is 2x, and the third angle is 3x, I know that if I add up all three of these angles together, that this has to equal 180 degrees. We're going to combine like terms on the left-hand side. That's going to give me 6x equals 180. And so when I divide both sides by 6, I get x equals 30. Now 30 is not my final answer. 30 is merely the multiple that I need to multiply to each element or component of this ratio to come up with my solution. So 1x, for example, is going to be 30 degrees. 2x, since x is equal to 30, is going to give me 60 degrees. And lastly, 3x is going to give me 90 degrees. And look at that. Those three angles are going to indeed add up to 180 degrees. So now, once again, it is your turn. Pause the video and try to find for C and D the perimeter for the first example, and for the second one, the angles of your triangle. Alrighty, let's take a look at how we did. So for the first one, the perimeter of a room was 48 feet, and we were given the ratio of its length to its width once again. So anytime we get a ratio and we're trying to find the missing parts, we want to apply this x to this, which will list out all the combinations or possibilities of something that is in a 7-to-5 ratio. So I come over here, here's my perimeter formula for a rectangle. 48 was perimeter, this is my length, this is my width, and now we just solved the equation. So we multiplied, we combined like terms over here, and lastly divided by 24. Once I know what the 2 is, remember the 2 is not my answer, 2 is merely the number that I need to multiply to my ratio in order to create a quantity that's going to meet the criteria. So my length here was 14, my width is going to be 10. For the last example for this portion, we have a triangle extended ratio problem again. So a 1 to 3 to 5, I apply an x to each quantity of the ratio. Since we know the angles of a triangle add up to 180, we set up our equation, we combine like terms, and we divide. Just like the last problem, once we find x, we need to go back and substitute that into each element or each angle of this triangle. So that's going to give me a 20-degree angle, a 60-degree angle, and lastly a 100-degree angle. So that'll conclude part 1 of this video, which talks about ratios. Be sure to check out part 2, which will talk about proportions, which is taking ratios and putting them into an equation format to solve for missing parts. Thanks for watching.